In this video, we're going to do 5 practice problems. We'll take the chemical formulas for compounds that contain transition metals and we'll write names for them. Now, the transition metals are the elements in this part of the periodic table here, and I've written in some of the most common. I'm also going to be talking about some of the metals over here, which are not technically transition metals, but act a lot like the transition metals in certain ways. Now, when we write the names for formulas that contain transition metals, those names often have Roman numerals in them, and we've got to figure out what Roman numeral to put there. So we'll get really good at that here. Now, if you need a little background before you get started with this video, I'd recommend you check out my video, Naming Ionic Compounds with Transition Metals Introduction, and also have a look at my videos on writing ionic formulas. If you're all good with that background, let's get started. Here's our first example, CrBr2. So Cr here is chromium. It's a transition metal. And like many transition metals, chromium can make a variety of ions with different charges. Chromium can make 3 ions. It can make Cr2+, Cr3+, and Cr6+. So when we name this compound, we have to figure out what charge chromium has here. It could be 2+, 3+, or 6+. Here's how we figure it out. The first thing we're going to do is we focus in on the ion with a definite charge. The ion that can only have one charge that doesn't change. And here, that's Br. Br is in this column, this 1- column, which means that in an ionic compound, Br always has a charge of 1-. Now, how much total negative charge do we have here? Well, there's this 2 after Br, which means that we have 2 Brs in this compound. So let me write another one in. And each one of these Brs has a charge of 1-. So that means that the total negative charge here is 2-. Okay, that's negative charge. What about positive charge? Well, in an ionic compound, you always have to have the positive and the negative charge balanced out. So that means that if we have 2- here, we have to have 2+ over here because they balance. Now we can figure out the charge on chromium. We have 1 chromium in here. There's no number after this, which means that we just have 1. Chromium is our positive ion, and we have 2+ of positive charge. So that means that this 1 chromium ion has to hold all of this positive charge because we only have 1 of them. So that means that the charge on chromium is 2+. So we have 1 chromium 2+, which gives us 2+ of charge, which is balanced out by 2- of charge that is contributed by 2 Br-. So that means the charge on chromium is 2+, and we can call this compound chromium. Now we need to say what its charge is, and we do this using Roman numerals in parentheses. So it's Cr2+, so we're going to use the Roman numerals for 2. So there's the 2. And now what do we call Br here? Well, the negative ion, Br- is called bromide. The neutral compound is called bromine, and so when it becomes a negative ion, we change the ending to IDE. So the neutral version is bromine, and that changes to bromide. So this is going to be chromium 2 bromide. Just a quick word of advice. Don't be confused with this 2. Some students think that it's the number that should come after chromium here, but that's not true. The 2 refers to the charge on chromium. Let's look at a few more examples. Okay, Au2S. So Au here is gold. And gold is able to make 2 different types of ions. Gold can make Au+ and Au3+. So we got to figure out what charge this Au has. We'll focus in on S. S is in this column of the periodic table, which means that it always has a charge of 2-. So here we got S, 2-. Now there's only one S. There's no number after that S. So that means that our total negative charge in the compound is 2 minus from this one S2 minus here. Now for the positive charge, the positive and the negative has to balance. So that means that over on this side we have to have 2 plus of positive charge. Now, what's the charge on gold on Au? Well, this 2 tells us that we have 2 gold ions in the compound. Here's one, here's the other. And this 2 plus is distributed between these 2 ions. So that means that each one, since we have 2 of them, is going to be Au1 plus. So now we have 2 Au1 pluses, give us 2 plus of total positive charge, balanced out by 2 minus of negative charge from our S2 minus. So we've figured out in this case that our charge on gold is 1 plus. So we're going to call this gold, and then we'll use the Roman numerals, gold 1 in parentheses. And for S, when S is a negative ion, S2 minus, we call it sulfide. As a neutral element, it's called sulfur, and then we add that IDE to the end of it when it becomes a negative ion. So again, this 1 here in parentheses refers to the charge on gold. It doesn't have anything to do with a number after gold. All right, let's do a couple more. CO3, N2. So CO here is cobalt, and cobalt can make 2 different ions. It can make a CO2 plus ion and a CO3 plus ion. What is its charge here? Let's figure out. We'll focus in on N, which is in this column here, which means that its charge in an ionic compound is always N3 minus. Now, what's the total negative charge here? Well, this is N2, which means that we have 2 of these, so I'll add an extra one. Now we have 2. And this means that our total negative charge is 3 minus plus 3 minus, which gives us 6 minus. Now, for the positive charge, the positive and the negative has to balance out, so that means that we have a total of 6 plus over here. Now for cobalt, CO, we have 3 of them. Let me draw them in here. 1, 2, 3. So how are we going to divide up this 6 plus amongst the 3 cobalts? We'll do it so that each one of them has 2 plus of charge. And that means that in this chemical compound, cobalt has a charge of 2 plus. So for naming it, we'll call it cobalt, Roman numerals here, parentheses 2, because that's its charge here. And finally, N3 minus, we call that nitride. The neutral element is called nitrogen, and then we add that IDE, cobalt 2 nitride. Let's do a couple more. These might be a little bit more challenging, so it's probably worth checking them out. ZNO. All right, this is kind of a trick question actually, because Zn is one of the few transition metals that can only make one type of ion. It always makes a 2 plus ion. Because there's only one possible ion, we don't need to use those Roman numerals in the parentheses. So we just call this zinc oxide. We don't call it zinc 2 oxide. Now, there's one other element on the periodic table that's a transition metal that only makes one type of ion, and that is silver, which always makes Ag, 1 plus. So, if you're naming a compound that contains zinc or silver, even though they're transition metals, you don't need to use the Roman numerals because they can only make one type of ion. Now, so far in all of our examples, the negative ion has been a single element, bromide or sulfide or nitride. But it's also possible for transition metals to form compounds with polyatomic ions, which are groups of atoms that together have a charge. So I want to do one example where we have to figure out the charge on a transition metal that's in a compound with one of these polyatomic ions. Here's our last one. V, then parentheses, CO3, 2. So the V here is vanadium, which is a transition metal that's able to make 4 different types of ions: 2 plus, 3 plus, 4 plus, and 5 plus. Now, the CO3 here is a polyatomic ion. It's the polyatomic ion carbonate. So, how did I know that? Well, obviously I wrote the question. But this is a good example of when it makes sense for you to learn the polyatomic ions, so that if you see them in a problem like this, you can just recognize them right away. So, to figure out the charge on vanadium, we need to focus in first on carbonate, our negative ion. So carbonate, CO3, has a charge of 2-. Okay, CO3, 2-. These parentheses and the 2 outside tell us that we have 2 of these carbonates. So let me write another one in here. CO3, 2-. And that means that for total negative charge here, we have 4-. Now that 4- has to be balanced out by 4+ of positive charge. And that positive charge is going to end up on this vanadium. There is only one of them. There's no number after it, so there's just one. So that means that this vanadium has to hold all of the positive charge. So it's vanadium 4+. So we're going to call this compound vanadium. Now the Roman numeral for 4 might be a little bit unfamiliar to you. It's IV. It's a good idea to memorize the Roman numerals at least up to 7, which is probably like the highest ion you're ever going to see. So vanadium IV for 4. And then as we said, this ion, CO3 2- is carbonate. So the name of this compound is vanadium 4 carbonate. This 4 is a charge on vanadium. So that is how we take the formula for a compound that contains transition metals and how we write a name for it complete with these Roman numerals.